Welcome viewers. So in this video lecture, we want to start this topic, number theory. So basically, in number theory, we study different properties of numbers. Okay, so we in this course are going to study that how to find the GCD of the numbers, how to check numbers they are prime or not. Okay, and then how to find the Bijout coefficient, what is a Euclidean algorithm, okay, and then what is Chinese remainder theorem, and then some topics of cryptography will also be taught. Okay, so we now start with the definition of divisibility. That what do we mean by divisibility? Divisibility. If A and B are integers, okay, with A not equal to 0, we say that A divides B if there exists an integer C such that that we can write B as A into C. Okay, so symbolically, or we can say mathematically, it is expressed like this, that A divides B. So the meaning of this is same as that B is in the numerator and A it is in the denominator. Okay, but we will use this notation for saying this thing, that A is dividing B. Okay, so whenever any number divides any other number, okay, then there must exist one integer, okay, such that B can be expressed as A into C. So for example, question is this, that check whether 3 divides 7 and whether 3 divides 12. Okay, so solution. See, when you divide 7 by 3, what is the answer? Answer is 2.333, like this. Okay, so it is a non-terminating number. Okay, so here we can say that on this side, okay, on this side, we did not get an integer. Okay, so that is why we can say that 3 doesn't divide 7. Okay, now next we check that does 3 divide 12 or not. So 12 by 3, what is the answer? Answer is 4, which is an integer. Okay, so we can say that 3 divides 12. Okay, likewise we solve one more question. For example, we want to check that 10 is divisible by 3 or not. Okay, so see, when we divide 10 by 3, what do we get? We get 3.333. Okay, which is not an integer. Okay, so it implies that 3 does not divide 10. Okay, so I hope that it is clear to you that how to check the divisibility, okay, of two integers, that any integer divides the other integer or not. Okay, now there are certain properties of division. Okay, properties of division. Okay, so what are these properties of division? We see them. uh, just 1 minute. See, the very first property is this, that if A divides B and A divides C, then A also divides sum of these two numbers. Okay, mean B plus C. Okay, if A divides B and A divides C, then A also divides B plus C. For example, if 2 divides 4 and 2 divides 8, so you can check it with your own eyes that 2 also divides 4 plus 8. 4 plus 8 means 12. So 2 definitely divides 12. There is no doubt in this. Okay. Now, so the second property is this, that if A divides B, then uh, we can introduce here one more integer like this, that A divide B into C. Okay, for all integers, for all integers C. Okay, for all integers C. Okay, means that if A divides B, then you can introduce here any integer C. Okay, still A divides BC. Okay, there is no problem in that. For example, if 2 divides 5, okay, then sorry, if 2 divides 6, sorry, if 2 divides 6, okay, then you see that I can introduce here any other integer like 3. Okay, still 2 divides 18. Okay, because 6 into 3 is what? It is 18. Now for example, if 2 divides suppose 12, then I may introduce here 12 into 5. So 12 into 5 is what? It is 60. So 2 still divides 60. Okay. So I hope you people have understood this property. Now the third property is this, that if A divides B and A divides and B divides C, and B divides C, then A also divides C. Okay. This is called transitive property. Okay, this is called transitive property, that if A divides B and B divides C, then A always divides C. Okay, so what I feel that all these properties, they are clear to you. Now we next want to talk about what is division algorithm. Okay, so what is division algorithm? Division algorithm. So what is division algorithm? This we see. Okay. So let A be an integer, an integer. Okay. And D be D be a positive integer, okay, then there exists unique unique q and r q and r q and r with this condition that 0 is lesser than or equal to r and r is lesser than d, strictly lesser than d, such that such that that a can be written as d into q plus r, okay, such that a can be written as d into q plus r. Here this q is called quotient, okay, q is called quotient and r is called remainder, okay. So q is called quotient and r is called remainder, okay. So notice here to these words that here we are saying that a is any integer, okay. So here you can take any integer, this may be positive, this may be negative, but d is what, d is a positive integer, okay. So when you divide any integer with a positive integer, you can always find q and r such that the restriction on this r is this, that it should be greater than 0. By that we mean that this remainder, it cannot be negative, okay. It is always greater than or equal to 0, mean the remainder can be 0 or it is greater than 0, mean it is always positive, but it should be less than divisor, okay. It should be less than divisor, such that you can write your a as d into q plus r, okay, where q is called quotient and r is called remainder, okay. So now we understand this division algorithm with the help of the following example. So the question is this, that question is this, that what are quotient and remainder when 101 is divided by 11. So this is the problem which we want to solve. So solution, you see here that we write 101 first of all and we want to divide it by 11, okay. So 11 nines are 99, okay. So what is the remainder here? Remainder here is 2. Now you were told this thing that dividend, this is equal to divisor is this, which is 11 into quotient, okay, quotient is 9 and remainder is 2, okay, and the remainder is 2, okay. So here if you write this in the division algorithm form, in that case it becomes a d q and r, okay. So now compare this with this. So what is the value of q? Value of q is 9 and the value of r is 2, okay. So you see that remainder here it is positive, so this is the answer of the problem, okay. But the thing is this, that if we want to divide any negative number by a positive number, then how to solve the question, okay. So the question is this, that what are quotient and remainder when minus 11 is divided by 3. So this is the problem which we want to solve. Okay. Now you see that write minus 11 on this side. Okay. Now here you see that if I write it like this, 3 into minus 3. I want to balance both the sides. Okay. 3 into minus 3. So it gives me 9, and if I add minus 2 in this, okay, and if I try to compare this with this, a equal to d into q plus r, then I get r value equal to minus 2. Okay, which is not correct. Okay, which is not correct. Okay, because you were told this thing that as remainder uh, is always a non-negative number. Okay, majority of students they solve the problem like this. Okay, so what is the other way to solve the question? This part is completely wrong. Okay, now minus 11, when you divide it by 3, okay, we want to balance both these. Okay, so right here minus 4, it gives me minus 12. So if I add 1 in this, okay, it becomes 11. Okay, so here a is minus 11, d is 3, quotient is minus 4, and the remainder is 1. Okay, so what is the question? Quotient is minus 4. Okay, and the remainder it is equal to 1. Okay, so this is the answer of the problem. But for your understanding, okay, I take one more question. Okay, so the question is this: what are the quotient and remainder when minus 17 is divided by 5? Okay, so solution: see, write minus 17 on this side. This is equal to 5 into minus 4, which gives me minus 20 plus 3. Okay, so it is minus 17 equal to 5 into minus 4 plus 3. So write it as write it as a equal to d into q plus r. Okay, if you like, then do not write this step. Okay, so what is the r value here? R value here is 3. Okay, so remainder here is 3, and what is the quotient? Quotient is minus 4. Okay, quotient here is minus 4. You do one thing, that you delete this step from here. Okay, delete this step from here. So in this way you can find the quotient and the remainder when any negative number is divided by the positive number. Okay, so now after this we want to talk about modular arithmetic. Okay, that what is a modular? What is modular arithmetic? Okay, what is modular arithmetic? So you see that in case of modular arithmetics, if a and b are integers and m is a positive integer. and m is a positive integer, then we say that a it is congruent to b modulo m if and only if m divides a minus b. Okay. So when we say that this number it is congruent to b modulo m if and only if m divides a minus b. Okay. Here the meaning of this is this, that when a is divided by m, okay, then it stores the remainder here. Okay, b is the remainder. Okay, when a is divided by m, so we rephrase this thing. Okay, b is the remainder when a is divided by m. Okay, so now we solve some problems based on this. Okay, and we want to check that any given number, okay, are they congruent or not. So for this purpose we will apply this definition. Okay, so the question is this: determine determine whether 17 is congruent to 5 modulo 6 and whether 24 and 14 are congruent modulo 6. Okay, so this we want to check. So it is very easy to check this thing. Solution: see here what you are given, that 17 is congruent to 5 under modulo 6 or not. Okay, so it is very easy. When do we say that two numbers they are congruent? A is congruent to b modulo m if m divides a minus b. Okay, so you see that check that 6 divides 7 minus 5 or not. 7 minus 5 is what? 12. So 6 clearly divides 12. Okay, so 6 clearly divides 12. Okay, so we can say that it implies that 17 is congruent to 5 modulo 6. Okay, you pay attention to this, that by this we mean that when 17 is divided by 6, okay, then the remainder is 5. Okay, so the other meaning of this is this. Okay, now next you check it for 24 and 14. So 24 is congruent to 14 modulo 6. Okay, now notice here that does 6 divide 24 minus 14? 24 minus 14 is what? It is 10. So 6 does not divide 10. Okay, so 6 it doesn't divide 10. Okay, so we can say that 24 it is not congruent. This symbol means not congruent to 14 modulo 6. Okay, this is not congruent to 14 modulo 6. I hope you people have understood this thing, that how to check that are these two things mean are these two numbers are they concurrent or not under modulo some number. Okay, so the next theorem is this. Next theorem is this, that let m be a positive integer. Let m be a positive integer. The integer, the integer, the integer a and b, okay, are congruent, congruent modulo, congruent modulo m, if and only if there is an integer, okay, k, such that a can be written as a equal to b plus k into m. Okay, so if we write this whole statement mathematically, so it means that a is congruent to b modulo m. Okay, if and only if a is equal to b plus you multiply k with this number m. Okay, so k into m. Okay, so it means that if you have this thing, okay, this can be expressed like this. Okay, or if you have this thing, okay, then this can be expressed like this. Okay, so we can move in both the directions. Okay, so now we see the solution of this. So solution of this, it is very easy. Okay, given that given that a is congruent to b modulo m. Okay, a is congruent to b modulo m. So what is the definition? It means that m divides a minus b. This is the definition of congruence. Okay, so now we know that if m divides a minus b, okay, so what is the definition of divisibility? Then there exists an integer k such that a minus b, it is equal to k into m. Okay, you were told about this thing. So a, it is equal to b plus km. Okay, b plus km. So this is the first part. Now converse. So what is the converse of this statement? That a is equal to b plus k into m. Okay, so it means that this can be written as a minus b equal to k into m. Okay, and k is what? K is an integer. Now as k is an integer, it means that m divides a minus b. If m divides a minus b, it means that a is congruent to b modulo m, because this is the definition of modulo. Okay, so we can move in both the direction, that if a is congruent to b modulo m, then a, it is equal to b plus k into m. Okay, now after this we want to discuss this next result. Okay, See, the next result is this. The next result is this, that let m be a positive integer. Let m be a positive integer. Okay. If a is congruent to b modulo m and c is congruent to d modulo m, then number one rule is this, that a plus c, it is congruent to b plus d modulo m. And the second rule is this, that a into c and b into d, this is congruent to modulo m. Okay, so very easy. This is very easy. Solution. What you are given? You are given that a is congruent to b modulo m, and then you are also given that c is congruent to d modulo m. Okay, so use the previous theorem. Okay, so what is the previous theorem? That if a is congruent to b modulo m, then we can write it as a equal to b plus m into k1. Okay, where k1 is an integer. Similarly, c can be written as d plus m into k2, where k2 is an integer. So sorry, k1 and k2, both these are integers. Okay, now we add both these equations. Okay, now adding 1 and 2. Okay, now adding 1 and 2. Okay, so what do you get? You get a plus c, this is equal to b plus mk1, okay, plus d plus mk2. Okay, so this is a plus c equal to b plus d plus, take m common, k1 plus k2, k1 plus k2. Now you bring this thing to the left hand side. So a plus c minus b plus d, this is equal to m time k1 plus k2. Okay. Now you see that as k1 and k2 are integers, so their sum, it is also an integer. Okay, so you see that from this we can say that m divides a plus c minus b plus d. Okay, so if m divides this thing, so we can say that a plus c, this is congruent to b plus d under modulo m. Okay, so this gives me the first part. Okay, now in the next part, instead of adding, what we do, we just multiply them. Okay, so we multiply these equations, equation number 1 and equation number 2. Okay, so you see that your first equation, it is a is congruent to uh, sorry, is congruent to b modulo m, and c, it is congruent to d modulo m. Okay, so we wrote these two equations in the previous part, that a equal to b plus m into k1, okay, and C it is equal to D plus M into K2, okay, and we said that this is equation number 1 and this is equation number 2, okay. Now you multiply A with C, okay. So what do you get? B plus mk1 into D plus mk2, okay. So multiply, so B into D, BD, then B mk2 plus multiply this with this mk1D, then next multiply this with this, okay. M into M is M square, K1 into K2, okay. So it is what it is, AC. Now bring this term to the other side, so it is AC minus BD equal to, take M common from here, take M common, so it is B into K2 plus K1 into D plus M K1 into K2, okay. So here this M divides, you can say that M divides AC minus BD, okay. Because you see that all these they are integers, so their addition, multiplication, it is also an integer. So as M divide sorry, AC minus BD, so we can say that AC it is congruent to BD under modulo M, okay. Now we quickly solve one example based on this, okay. We want to apply the same results, okay, for solving the question. Like 7 is congruent to 2 modulo 5. By that we mean that when we divide 7 by 5, the remainder is 2. So there is no doubt in this. So it is perfectly fine. Now 11 is congruent to 1 modulo 5. It is also perfectly fine when 11 it is divided by 5, then the remainder is 1. Now if we add these two, means 7 plus 11, okay. So the remainder of this is just given by adding these two, okay. So 2 plus 1, what it is? It is 3 modulo 5. So you see that on this side you are getting 18, and when 18 it is divided by 5, okay. In that case it stores the remainder 3, okay. So you see that how useful is the previous theorem, that if you know that A is congruent to B modulo D, B modulo M, and C is congruent to D modulo M, then A plus C it is congruent to B plus D modulo M, okay. So now likewise we can perform multiplication operation. So 7 into 11, okay, mean the remainder of this will be same as when you multiply 2 with 1, okay, under modulo 5, okay. So 7 into 11 it gives me 77, okay, and on this side what do you get? You get here 2, okay, under modulo 5. So you see that how quickly it is giving me the result, that when 77 it is divided by 5, then the remainder is 2, okay. So thank you very much viewers for watching this video. More about it will be discussed in the next video lecture. Okay, thank you very much.